Alright, hey guys, welcome to this video which will show us some examples for standard deviation. These examples have come from the Cambridge Mathematics 5.3 textbook. Our first example here is calculate the mean and standard deviation for this small data set correct to 1 decimal place. Now, remembering that the mean is the sum so that's the uppercase sigma of the scores over the number of scores. So for this one we'll have 2 plus 4 plus 5 plus 8 plus 9 all over 5, and if we actually put that into our calculator, alright, so what have we got? We've got our fraction key. Always best if you're going to need a fraction, put the fraction bit in first, unless it's like the second bit, but before you actually start typing it in. So 2 plus 4 plus 5 plus 8 plus 9. Using our down cursor over 5, hit the equals. And it says there 28 over 5, but if you remember, there's a special button in the bottom row of black keys there on my calculator that has an S, a double-sided arrow, and the D. Alright. So it is there, it is the standard form to decimal form. If I click that button, it tells me it's 5.6. Alright, so 5.6. There's our mean. Now our standard deviation, we can actually do this using that formula, and then I'll show you how to use the calculator to do it as well. So our formula, oh no, I won't do that way. Alright, so is our first x minus the mean squared plus the next x minus the mean squared, and all the ones in the middle. Nth all over n. So in our case here, we want 2 minus 5.6 all squared. Alright, and we're just going to keep going until we're got all of the numbers in. And you can see there that I'm just going fairly methodically to make sure that I get all of the numbers in. Okay, so that 9 is our nth term, all over n, and then we can type that into the calculator as well. So let's clear that. So we're going to start with our square root sign this time, chuck in our fraction, and then just type straight in to the calculator. Okay, now I've skipped ahead to the end of that, and you can see the answer there. You can't actually see the writing behind the calculator there, but you can see my answer on my calculator is 2.5768, etc., etc. So we can round that number off if we want 1 decimal place. So we cut it off at between the 5 and the 7. 7 is above 5, so the 5 needs to go to a 6. So it's 2.6 for the standard deviation. Now we can actually do all of that in a calculator without going through all of that rigmarole and working. So I'll show you that one now, and I'll just make my calculator a little bit bigger, so you'll be able to see that a little bit more effectively, what I'm about to do. Okay. So I'm going to clear that away. Now, remembering the steps that we went through to enter in data. You need to go to data mode and pick 1. Now, I have turned on my frequency column. Not necessary at this point, but if it's there, it's there. Don't worry about it. Okay? And we just enter in our data. So we hit the number for the data and it equals to enter it. Into my last one, I hit equals there to enter that data, AC to clear it away. Now it's starting to rumble a little bit inside the calculator's mechanisms, inaudibly obviously. Shift 1 gets me to that option screen. 4 gets me to where I'll find my standard deviation of option 3. You can see I got that little sigma. There's my standard deviation straight away. Much easier to do if I go back through that process. Go into 4. If you look at option 2 there, option 2 is your mean. There's our mean. You can see that process took way less time. In fact, it took less than a minute and a half. So let's use that process for our work in the near future. Okay, I'll just reduce the size of my calculator again. And let's have a look at the next example. Alright. We have a back-to-back stem and leaf plot. We've seen back-to-back stem and leaf plots before. So these should be not too difficult to figure out. And it shows the distribution of distances that 17 people in Darwin and Sydney travel to work. So obviously we've got our Sydney side and our Darwin side. The mean and the standard deviations are given. So there's Sydney and there's Darwin. Don't have to do any working out for this one. Okay, now I'm just actually going to get rid of my calculator here. Just because it's going to be a little bit in the way. Alright, so there's our questions. Consider the position and spread of that data and then answer the following questions. By looking at that stem and leaf plot, suggest why Darwin's mean is less than that of Sydney. Suggest why Darwin's mean might be less than Sydney's. So if we look there, the maximum score for Darwin is 35. Alright, Darwin's max score is 35. It's pretty straightforward. If that's the max score and the max score for Sydney is 52, that's going to automatically have an effect on the mean. Okay, so because the higher score for Sydney is far greater than that for Darwin, Darwin's mean is less. So we can even write that in. So Darwin has a lower maximum score than Sydney. That's the big issue. So just simply mathematically, maximum scores, there's such a discrepancy there. Of course there's going to be a discrepancy in the mean. Okay? So remembering, like, most people in Darwin are going to be working and living inside Darwin, because once you get out, oh goodness me, the distances grow. But inside Sydney, Sydney is such a big, sprawling city that you might work in central Sydney but live on the Central Coast, for example, which is quite a big distance. Question B is, why is Sydney's standard deviation larger than that of Darwin? So again, it's to do with how big that spread is. So it has a greater range. Right? So Sydney has a greater range. Alright, so because there are more scores to work with, and because there are more scores below and more scores above, those squares are going to be much bigger. Okay, so those deviations are going to be larger than that of Darwin's. You can see there in that spread, the Darwin scores, alright, much closer together than the Sydney scores. Alright, so these ones are spread out. So the greater the range, the greater the standard deviation tends to be, simply because there is a bigger possibility for bigger deviations. Okay. Last question, give a practical reason for that difference in the centre and spread for the data for Darwin and Sydney. So as I said before, okay, Sydney's population is far greater than that of Darwin. So it has to live further afield. So that's pretty much it. And that just requires, obviously, greater distances. So the further away from work you live, the further you have to travel to get to work. That's the long and the short of it. So that is some. So we calculated a standard deviation both by hand and with the calculator, and then we applied standard deviation and the mean to analyze a little bit of data. Have fun doing your questions.